My name is Dan Miller. I've been with Hazard Control Technologies for about 2 years now, and I, in my previous life, was a fire chief and a firefighter with the Omaha Fire Department in Nebraska, as well as the Columbus Fire Department. Been involved in the fire service since I was 16 years old, and involved in technology, and really excited about encapsulator technology, and excited to share it with all of you. Hazard Control Technologies is located in Fayetteville, Georgia, just outside of Atlanta, but we do have a worldwide distribution network. We're an ISO 9001 company. Our main flagship product, the F500 encapsulator agent, is really reaching a larger audience now, especially due to a couple of issues. Number one, the fact that most of your traditional foams like AFFF and alcohol resistant AFFF have a lot of forever chemicals in it, the PFOS and PFOAs, that can cause not only environmental damage and are very pervasive throughout the world, even in the Arctic and Antarctic, but they also are a health hazard with the chemical, with the cancer-causing agents, and those are the same fluorinated agents that are suspected of causing cancer in firefighters and people who might be exposed to them frequently. And then the other big issue is the lithium-ion battery problem that we're all kind of dealing with, or getting geared up and ready to deal with. That's become a big issue for us as well. And the one thing that F500 really is strong at is cooling and encapsulation of gases and hydrocarbons that cause fire, or that actually burn. So we're the recognized chemical worldwide as the only chemical that has been third-party tested and proven to put out lithium-ion battery fires. So, but today we're talking about roadside hazards in general, things that firefighters and fire departments run into frequently in the fire service, from collisions to vehicle fires, spills and leaks, etc. And one thing you'll find about our agent is that it's environmentally friendly, very effective. It's also friendly from a health and safety perspective. So we're gonna hit on all of those topics as well. Nice thing I like about it, being a firefighter, fire chief for years and years, is the fact that it's a very versatile agent and can be used for many of our typical day-to-day fire service concerns. So the things we're going to talk about today, however, and focus on is achieving a better understanding of the hazards associated with roadside incidents, how we can help mitigate those hazards using encapsulator technology, discuss why current agents fail to extinguish three-dimensional fires, and we'll talk about what three-dimensional fires are if you're not familiar with that term. We're going to talk about what a spherical micelle is and how it works, and how it works to encapsulate hydrocarbons and toxic gases and things of that nature that really help us out from a fire perspective, as well as a hazardous material and vapor producing perspective as well, and how we can limit that. We're going to identify how F500 encapsulator agent interacts with all of the four segments or legs of the fire tetrahedron, and why that's especially important when we're responding to collisions that involve flammable liquids, lithium-ion batteries, metals fires, tire fires, etc. Identify what percentage of F500 you're going to use on the different classes of fire, and especially when we're dealing with roadside collisions, automotive fire. So our roadside incidents include crashes, of course, and the things that happen as a result of crashes, the fires and the fuel spills. But having been on a member of a hazmat team for 8 years in a metropolitan class city, there's a lot of crazy things that happen on the roadways in the period of a day. Going down the interstate, you can hit an object dropped by another vehicle, and it can split open your fuel tank. You have brakes on trucks that catch on fire and then end up catching the cargo on fire, whether that's dry cargo of some sort or a tanker or whatever it's hauling. And then we're going to talk a little bit about the cost effectiveness of F500 encapsulated air agent as well, and the fact that it can, number one, since it is more effective, it can get us off of that roadway quicker and back into service and reduce the danger. So the dangers of operating at a roadway incident are many. According to a report from NFPA, 8% of firefighter line of duty deaths in 2019 were from being struck by a vehicle while operating on a roadway. I know several firefighters personally that have been struck by vehicles on roadways, some that survived and some that didn't. But it's always a danger, and many of us have really taken measures lately to keep from being struck by other vehicles, putting out buffer vehicles at our crash sites, etc., which is a very good plan. Again, the nice thing about an effective agent like F500 is that it lets us get out there, get our job done, and get off the roadway quicker. Because as we know, nobody looks up anymore, they're all looking at their phone. The roadway's not the same as it was 10 or 15 years ago. We're switching largely to electric vehicles and hybrid vehicles, but the roadway's also not the same because people aren't watching where they're driving anymore, and speed limits have gone progressively upward, and it's just it's a different roadway than I grew up knowing, and we have to be ready for those changes. So major automakers like Ford and GM, for example, are pledging to have 50% of their products by 2030 be electric and eliminate the internal combustion engines in those. There's also a lot of over-the-road heavy truck manufacturers moving towards being electric. Tesla, Kenworth, Freightliner, there's a lot of them moving in that direction. So you're going to see more and more of an emphasis on that as we move forward. And those vehicles are going to become involved in crashes. And like I try to emphasize to other firefighters and fire departments that they're very rarely in a situation where you can just let them burn. So we need a solution to put them out. There's almost always hazardous exposures, whether that be people trapped inside of a vehicle that's been in a crash, other people around the vehicle runs into a building, whatever it may be. There's almost always some kind of exposure that keeps you from just letting it burn itself out. That's not a solution. We're going to provide you with a solution. So talk about the different classes of fuels that are in roadside emergencies. When we start with Class A, but Class A materials that we're going to talk about are largely manufactured out of Class B material. And number one is tires, and we also know that tires are very difficult to extinguish. There's 6 to 8 quarts of oil that make up every just passenger car tire, much more in a truck tire. And they have steel belting in those tires, and they burn very hot, and they're difficult to put out. Plain water typically fails at putting them out unless it's just 1 or 2 tires. And foam doesn't do a very good job either because it's a 3-dimensional object, and you can't make a blanket over a 3-dimensional object very easily. And that's what foam is for, is making a blanket. And so that doesn't really work for Class A fires like tires very well either. And cargo in trucks and so forth, you can run into all kinds of different Class A materials in a truck. Class B materials, Obviously, there's a lot of those that are involved in roadside emergencies, fuel tanks that get split open in collisions, oil dropping out of the crankcase of an over-the-road truck, saddle tanks on the over-the-road truck can hold hundreds of gallons of fuel. There's just a lot of Class B hazards, and even what we would say are the solid fuels in a class in a vehicle, although we may refer to them as Class A, most of them are manufactured out of Class B chemicals. So when they start to burn and break down, they kind of more or less turn into a Class B fire as they start to pyrolyze and decompose. So a lot of these fuels are going to fall somewhere in between the Class A and B. Class B materials have also evolved over time. We're not just dealing with straight hydrocarbons anymore. We're not dealing with diesel and pure gasoline anymore. We've got all from gasoline with MTBE in it, E10, E95, so your different ethanol mixtures. We've got biodiesel, heptane, crude oil, and there's a lot of synthetic oils out there as well nowadays. So the good thing about our F500 encapsulator agent is compatible with all of those fuels. So you're not having to use a different agent for different fuels. Three-dimensional fires. So anytime we have a three-dimensional object involved in a liquid ignitable fire, that's an example of a three-dimensional fire. And if that fuel happens to be running, could be running down a gutter, running down into the ditch. But if you look at where the fuel pump is in most modern vehicles, especially passenger cars and pickup trucks, that fuel pump is electric and it's inside the fuel tank. So if it's still got power, if that fuel line's been severed, it could be pumping that fuel out. So you're dealing with a liquid ignitable that's under pressure, flowing, moving. It really, really complicates your incident. And it precludes foam from making a blanket over that running fuel and or three-dimensional object. The foam just runs off. So foam is not a very good solution for three-dimensional fires. It actually says and refers in the annex of NFPA 11 on foam that foam is not applicable to three-dimensional fires. So we have to have a little bit of a different solution there, and that's where F500 excels. Well, I'm hoping this video or set of videos works out okay. You'll have to let me know. Can you hear the sound?
No.
No sound.
No sound.
All right. Let me see if I can figure that out. There's sound. There we go.
Oh, yes.
Okay. So,
are you flowing foam? He's going to. That's our plan. I mean, we got a straight tip on there. What's that? We got a straight tip on there. Make sure he's putting it on the fire.
so there are some complications with trying to flow foam and or dry powder. Number one, you need specialized nozzle.
Get underneath.
You need to aspirate it with some air. Create foam. So your straight tip nozzles don't work. Clog nozzles don't perform that great with foam.
Stay right there.
Yeah, size that up. And I'm going to have an inch of stretch.
Skip ahead a little bit here. 45-minute video. I don't think we want to. letting me skip ahead. There we go.
It's not charging the video.
Not allowing me to go forward. But if you'll see, it's a 45-minute video. So they're out there for 45 minutes dealing with the problem on the roadway. If we could handle it much quicker, that'd be better. We've got an airport truck attacking a vehicle fire on a roadway on the.
It felt it was one of the two, but it was great. Great
Let's see
action
how
on those,
effective it is.
on those people.
Well, thankfully, they were there to be able to help them. So he says it looks as if this possible tanker lost its brakes and just slammed into the median.
Yeah, you know, it was either something had caught on fire or they had lost brakes. Something malfunctioned with that truck that it was engulfed in black smoke and then started on fire as he slammed into the median.
Well, we are still watching. The firefighters are now moving back in a little bit closer into this fuel tanker, but we can see massive flames. Thankfully, the road crews were there to help that driver get out, but you said he was on fire as they pulled him from that cab.
That is correct. His right pant leg, I believe, was engulfed in flames, and you could see him. He looked like he was in pain because he tried to get up and then fall right back down. I mean, that other gentleman, why that truck was completely engulfed in flames, ran right next to him, right in the heart of the danger, and really helped him turn around and securely get the thing out of harm's way.
Well, we have been told that that driver was transported to the hospital. His condition right now is unknown. We don't know how serious injuries are, but a huge thank you to that person who jumped in to pull him from the cab of his truck. It is scary as you see this video. The fire is so intense.
Yes.
But you can see the dry powder had limited effectiveness on that Class B liquid ignitable fire. A lot of it. One of the downfalls of a dry chemical or dry powder is that it doesn't cool. So you have to keep applying it until the natural cooling would take place. And if you run out before natural cooling takes place, the fire just reignites. So both with the foam and dry powder, there are complications that a lot of us have run into over the years. That number one, with the foam, it's difficult to apply a nice, good blanket to something that's a three-dimensional object, and it usually fails, and you have to apply a lot of it. With modern chlorine-free foams, it can take 1.5 to 3 times as much chlorine-free foam to do the same job as the legacy AFFF does. So you have to carry a lot more, you have to apply a lot more, and you have to keep applying a lot more to have the same effect. So there are some limitations to both of those technologies. A little closer picture of the aftermath there of one of those fires. You can see they tried to apply some foam here, and eventually they gave up and had to back out and let it burn. So here we have the unfortunate incident where there is a human life involved, and you see they're trying to apply a foam agent out of an extinguisher, and it's just not doing the trick with the volume of fuel that they have, and the fact that it's on a three-dimensional object. They're just not able to overcome that heat release rate of that liquid fuel, and you've got a victim in there. they just don't have near enough extinguishing capability and cooling capability with the type of extinguishment that they're using. Yep. I'm going to skip a couple slides there.
See, in the video,
There we
that you
go.
have the Dan, in the video that you have the incident of the race truck, you have almost 10 fire extinguisher that they try to say the pilots, but they cannot extinguish the fire.
Right. Yeah, and it kind of goes back to what I say. As Hernan says, they had almost 10 fire extinguishers. They were unable to extinguish that fire. A lot of the modern fuels, they just burn a lot hotter and a lot more rapidly, especially when you're involving some ethanol blends. And that was probably a race fuel of some sort, so it probably had some really high octane blend in it. But you've got to have a lot of cooling power to overcome that heat. Talking about a foam where you're trying to create a blanket, that blanket's going to be very difficult to establish and maintain if you've got a three-dimensional surface that you're trying to cool. And then the fact too is if you're trying to create a foam blanket, foam tends to hold that heat in. It puts a blanket over the object, just like you put a blanket over yourself at night to stay warm. It will actually hold the heat in. So if you have objects within that fire that are hot enough to reignite the fuel, they're going to continue to make that fuel vaporize and pyrolyze and burn off. So you gotta be able to overcome the heat release rate with cooling power, as well as be able to create a blanket at the same time if you're going to use a foam type of a product. And again, with dry chemical kind of extinguisher, not only do they not cool, but you're interrupting the chemical chain reaction there. You've got to keep doing that until that fire would naturally cool down, and or the objects within it, whether it's steel, magnesium, whatever might have been involved with that car. As long as that stuff stays hot enough to keep reigniting that fuel, it's going to keep reigniting. So you would have to keep applying it for a long time if it were a dry chemical agent. So we ask ourselves the question, what does my department do to make auto accident scenes with fuel spills safer? I've seen a lot of departments try different methods over the years. One of the things you can do is put down a layer of foam, but then you've got to try to maintain that blanket of foam while your personnel are working in it to try to do extrication. And the very nature of that kind of defies keeping a blanket over it. So every time someone shuffles through it or wheels a gurney through it or drags a hose from an extrication tool through it, it's disturbing that blanket. And it can also be slick and cause complications and in many different ways to your scene. Plus, it takes more personnel. A 2-second video. That's a shorty. But we're gonna help you with a better solution. Class D materials. There's a lot of high strength, low alloy materials in vehicles nowadays. A lot of magnesiums for side impact protection, lightweight strength, so the vehicle makes a good protective capsule for the occupants that are riding in it, so that it can absorb a lot of energy and stay intact. There's a lot of magnesium that goes transverse across the body from side to side between the frame rails and from A pillar to B pillar, or excuse me, A pillar to A pillar and B pillar to B pillar. There's more of it, so it has that side impact protection as well. Things like steering column, wheels, front end suspension components, components can all be made out of things like magnesium. So when that stuff actually starts on fire, and at some point in the vehicle fire, it usually does, it can be very difficult to extinguish. It can burn upwards of 5,000 degrees. And then when the water hits it, as most of you know, it separates into the hydrogen and oxygen and just excites the fire almost into an explosive state. All of these are components that can be made out of magnesium. You've got your radiator saddle in the front end, engine components, dash components. You've got drivetrain components like transfer cases and so forth. Seat frames so that the seat stays intact in a side impact, for example. Steering wheels, steering columns. Got object number 11 there. If you've got a space frame or a uniframe type vehicle, that can be the framework that's either in front of or behind the passenger compartment. Just a lot of different vehicle parts nowadays that can be made out of magnesium, and it's really up to the vehicle designer and their imagination as to where they put it. Again, it lowers the vehicle weight and maintains the strength. When it comes to hazardous materials, there's more than 3 billion tons of hazardous materials shipped every year, and the trucks, over-the-road trucks, transport those, of course. Not only the fuels and oils in the vehicle, they're propelling the vehicle down the road, also what they're carrying. So approximately 94% of the daily shipments include some type of hazardous material or hazardous waste. Now it started going on its own. Trying to get it to stop and back up here. All right, did that. There we go. There we go. So most of you have run into train and tanker accidents in your territories. So in Chile, we had an incident where there was a sulfuric acid leak from an incident, and they were trying to find a way to safely mitigate it without reaction. And if you've ever dealt with a sulfuric acid leak, you'll know that dilution is not the solution to pollution on those, and that if you apply water, you can have a violent reaction. Well, one of the nice things about our agent, F500 encapsulator agent, is that you can apply it to incidents like sulfuric acid incidents and not have that reaction and neutralize it. It's also environmentally friendly.
See here in this video, sorry, Dan, this was in Chile with 6,000 liters of sulfuric acid, and a field response company started to throw water. The water started to heat more than 100 centigrade. I started to have vapors. When this fire department started to use the encapsulator technology, the thermal reaction stopped in 60 centigrade, and they can decrease the gases that start to involve or start to bother a jail close of this, an office of a mining close of this incident. And in a few hours, they can finish, they can put the all on safe without vapors, and they can open the speedway.
Thank you, Hernan.
No problem.
So this next incident was in Arizona. Go back. Keep skipping forward on me. Sorry. Carrying 8,000 gallons of gasoline and diesel, went off the roadway. They were able to you have more information on this one too, Hernan? Hernan,
Yes.
do you have more information on this one as well?
Yes, and this information, this tank roll over under the mountain, and they have a little amount of product, and they use 0.5% to encapsulate the vapors when the fire department start to try to close the valve and to move all the tank.
Do you want me to take over on that, Hernan?
Oh yeah, Ron, please.
Oh, you're with
Yeah.
us now.
Yeah, I'm on my iPad. So
Oh, okay.
Welcome back.
yeah, so that was a gas tanker rolled over the side of the highway. So they were using F500 while they strapped the tanker. So the state came in, set up some remote combustible gas monitoring at the bottom of the hill. They were applying a 3% solution of F500 while they rolled the tank truck to dump the fuel out, and continue to encapsulate that fuel both through the offloading process and then using a crane, actually multiple cranes, to lift the tanker back up onto the highway. They were using a 3% solution F500 to both encapsulate the fuel and keep those explosive vapors mitigated to make it a safe work environment to get that trailer back up onto the highway.
Thank you. So the other big thing that concerning us all nowadays is that ion batteries beginning to find their way into the vehicles in every community. You're seeing more and more Teslas, but there's also a lot of other brand names out there, Chevy, Ford, etc. They're manufacturing EV vehicles now, and those lithium-ion batteries are not only going down the roadway, they're parked in garages, they're residential homes, they're parked in parking garages. They're in all kinds of situations. They're in collisions, rollovers, you name it. They're subject to all kinds of roadside hazards and hazards that fire departments are going to end up dealing with every day, and that problem is just going to continue to grow. And not only in vehicles, but also in things like e-scooters and so forth. So with these new technologies comes new hazards. As of right now, lithium-ion batteries, they kind of fall under Class A by NFPA, but there are, really kind of in a class by their own as far as how you have to go about using them. They create a lot of off-gassing when they're on fire. Hydrogen fluoride, hydrogen cyanide, carbon monoxide are all example gases coming off of that fire in high volumes. And then the fire itself, since they're very well encased and enclosed, has a lot of heat buildup. And that buildup is what really keeps that thermal runaway from propagating from cell to cell to cell inside of these giant battery packs in these cars, and keeps that fire growing. And there's shrapnel coming off of it. It's a very intense fire. And then one of the biggest problems with the traditional extinguishing agents, whether it's water, foam, dry chemical, CO2, is none of them really have the cooling capability to deal with the heat release rate, and especially the heat release rate in that configuration that those batteries are in, packed tightly together within enclosures in these vehicles. They just create a unique situation as far as what we're used to dealing with, and the heat signature coming off of that situation, and getting the cooling ability to the batteries. And that's what we're going to provide you with a better solution for. when you think about how your department would approach a lithium-ion battery fire, we know that departments are applying anywhere from 10 to 40, 50 times as much water as they would an internal combustion engine vehicle of the same size. And they're really not putting the fires out. They're just cooling the exposures until the fire runs out of fuel and energy. So kind of like a barn fire. If you've ever been to a barn fire, you'll know that, well, that barn's probably going to burn down, and we're going to save the foundation and everything around it, but probably not putting that barn out. So, and again, there's always exposures to these fires, so it's not a solution to just let them burn. This is the one that happened down in Texas.
Deadly crash involving one of Tesla's cars with an autopilot feature. The car slammed into a tree and burst into flames. Police tell ABC News it appears no one was in the driver's seat. Here's ABC's Gio Benitez.
Tonight, mystery surrounding a deadly crash near Houston involving a Tesla Model S. The charred wreckage captured on camera after it crashed into a tree and burst into flames. 2 men inside were killed. The Tesla's high-energy battery reigniting over and over again. Firefighters trying to put the fire out for 4 hours with more than 30,000 gallons of water. The fire eventually put itself out.
Again, this fire eventually burned itself out, ran out of batteries to burn, and went out. So, to me, that's not an adequate solution. As a fire chief, I know that's not good enough. We need to find a better solution for that, and I believe we have it. So, F500 encapsulator agent, as I've alluded to a few times throughout this, is a better solution than many of these problems. It's a very versatile agent. It works on a completely different basis than foam, and it's covered under a different NFPA section, NFPA 18A. And we're going to talk a little bit about how it works on a chemical molecular basis rather than creating a blanket. So F500EA is a fluorine-free, non-corrosive, biodegradable encapsulator agent. It's rated multi-class in both Canada and US by UL and NFPA. It's a combustible, flammable, vapor and liquid spill mitigation agent. So, and that's a lot of word salad, to be honest. But as we break it down, I hope to be able to show you that it really has a lot of capabilities that it may not reveal to you on the surface. I've been studying this stuff for quite a while now, very intensely, and I learn something new about it every day myself as to how it works and interacts in these different emergencies. So encapsulator agents are a type of water additive agent. They're not just a class A foam. They're not just a surfactant. The basic building blocks of an encapsulator agent are what we call spherical micelles. Spherical micelles are capable of encapsulating carbon molecules as well as polar and nonpolar hydrocarbon vapor and liquid molecules. So we interact with the fuel, whether it's a liquid and we mix with it, and or in the vapor space immediately above the fuel. It's how an encapsulator agent separates fuel from the oxygen on a chemical molecular basis, as it traps those carbon and hydrocarbon molecules inside of the spherical micelle and locks them up. And it does so permanently. This video is going to show you how the spherical micelles are formed in the water droplet, as well as how the F500 molecule sets up on the surface of the water droplet.
Encapsulator technology, the next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic nonpolar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the nonpolar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The nonpolar tails orient outside the droplet, with polar heads on the surface, forming an EA skin on the surface of every droplet. In addition to the EA skin, there are millions of molecular spherical micelles within each droplet.
So if you look at the structure of that water droplet, you'll notice on the surface is a coating of F500 molecules with the nonpolar tails sticking out and the polar heads adhering to the surface of the water droplet. And the polar heads actually dissolve in a kind of a film on the surface of the water droplet. And then inside of the water droplet, the spherical micelles establish themselves, and the nonpolar tails point in because they fear that water, so they're going to point in on the inside of the water droplet with the polar heads pointing outward. So you get those little golf balls in there that are the spherical micelles, and there's actually millions and millions of those in every droplet of water. And if you also take into account that F500 has a surfactant characteristic, each water droplet is smaller than a plain water droplet. So we have more water droplets and much more surface area. And between that increased surface area, smaller water droplets and more of them, as well as the structure of the water droplet and how it's altered by the F500 involvement and influence on it, is able to absorb heat much more readily than plain water. And it does so very well. And that's one of the things that makes it work so well in a lot of different situations. So again, the head of the F500 molecule is what we call a polar or hydrophilic head, and it loves water and it's attracted to the water. And then the other end of the molecule is a nonpolar tail, and it's hydrophobic or fears water. It's not soluble in water and doesn't dissolve. And then as the F500 encapsulator agent concentrate is proportioned into the water stream, it readily mixes with the water. And then as it comes out of the nozzle, each surface gains a coating, each water droplet surface gains a coating of the F500. And then inside of each water droplet, millions of spherical micelles are formed. As a part of that, process, it absorbs heat very, very readily. It's a transition that occurs instantaneously. And then as those water droplets fly through a vaporous atmosphere that maybe contains a flammable vapor, it's encapsulating those hydrocarbons, the vapor. And then as it strikes the surface of a liquid ignitable fuel, it readily mixes with it. And we use kinetic energy to purposefully mix the product with that fuel. We're not applying it gently like a foam. And then that helps it mix and encapsulate the liquid fuel as well. So on a chemical molecular basis, you're able to interfere with each segment of the fire tetrahedron. We're excluding oxygen by trapping the hydrocarbon inside of the spherical micelle and locking it up and not exposing it to oxygen or oxidation. The fuel, we're making it not fuel anymore by readily mixing with it, encapsulating those hydrocarbons and turning it into an inert waste material. The heat, due to the structure and size of the modified F500 water droplet, We're able to absorb anywhere from 10 to 30 times as much heat as plain water. And then also, as a part of that, interrupts the chemical chain reaction, the ability of the fuel to oxidize. As a result of that, F500 is compatible with all classes of fuel. So your class A's, B's, metals, lithium-ion batteries, etc. We've also got a lot of testing that's been done by Con Edison of New York and New Jersey, and they've worked with us on testing to show how it can be applied to up to 345,000 volt electrical services with a reasonable standoff distance and a broken stream, of course, that make it evident that it does not transfer electricity near as well as plain water. So it's applicable to transformer fires and things of that nature with a little bit of training and common sense. So the encapsulator agent has a few different superpowers. Number one is encapsulation. Encapsulator agent drastically reduces the risk of ignition and reignition, has great burn back resistance. The fact that it encapsulates those hydrocarbons inside of the spherical micelle allow it to really absorb a lot of heat, readily mix with the fuel, turn the fuel into an inert waste material, and cool objects within the fire very, very rapidly. I'm not seeing the little play button. Get off my screen. Not letting me play the video. Sorry about that. So I have to move on. I can pull up another Class B fire for you after a little bit and show you how quickly it extinguishes Class B fire. Again, we don't create a blanket. We're mixing with the fuel, so we're aggressively sweeping the stream across the fuel as we're approaching, and the fire goes out very quickly. So, kind of puts that slide out of context, so I'll move on to this one. So one thing to be aware of if you're looking for a replacement for your foam, and or you already have replaced some of your foam with fluorine-free foam, or what we call triple F or F3, it can require 1.5 to 3 times as much fluorine-free foam to have the same effect as a legacy AFFF or AR AFFF, and then you have to keep applying it as well. It breaks down more easily than the old stuff did, because that, the fluorinated agents in there really is what made that stuff work very well and set up that nice film on top of a liquid ignitable fuel and kept it from burning. They have a much more difficult time making that happen with a fluorine-free foam. So the benefits of encapsulation: you don't need a foam blanket, so it works on 3-dimensional objects that are on fire, even if they're in a pool of liquid. Remove their flammable vapors immediately and we encapsulate them, so we keep ignition from occurring. The environment is not harmed by application of encapsulator agent. Is totally biodegradable, and actually as it accidentally or purposely gets washed into the soil, it actually increases microbial activity and is beneficial to the microbes, and they eat it up, and then the fuel disappears. The vapors disappear right away as they're encapsulated. Liquid fuel is made inert. Anything that washes into the soil gets eaten up by the microbes, as long as you apply enough. And we have a formula for that, called the 1:8 to 40 formula. And as long as you apply it at the right rate based on the size of your spill, or what we assume is the number of gallons that have been spilled. You can encapsulate the entire spill and make it a non-environmental incident item. So there's less cleanup, you get off scene faster, you don't have a foam residue to build up, built up that you have to take care of. And actually, when you apply water and or foam or a combination thereof to a fuel spill, it just spreads the contamination. It doesn't mitigate it in any way. When you apply F500 encapsulator agent, it takes away the flammability and it treats the environmental hazard as well at the same time. In 2018, there were approximately 212,000 vehicle fires, including 560 deaths and 1,500 injuries. My own cousin and my neighbor's kid got in a head-on collision near my hometown here in Nebraska in 2018, and both of them were caught up in a vehicle fire, and both of them died as well. So that's a loss that hits home for a lot of people. Property loss from those incidents were almost $2 billion. So I'm going to show you how F500 encapsulator agent can make a difference.
If you want, Dan, I can share my screen to show the video.
That would be great.
Okay, give me a moment.
No arrow on my end.
Okay. I need to share this screen.
Screen is yours. So this is one fire extinguisher with F500 encapsulator agent in it. Just a pressurized water cannon extinguisher with 3% F500 and water.
I can start to pass the slides, Dan.
Yeah, you do that and I'll talk. How's that? Okay. So rapid cooling is the next superpower of F500 encapsulator agent. The droplets create a thermal circuit. Number one, there's more of the droplets. They're smaller, so there's a greater surface area. Each of the water droplets is modified with the F500 molecule on the surface with the nonpolar tail sticking out that helps it absorb heat into the surface of the water droplet. And then inside of the water droplet is the millions of spherical micelles, which also readily help absorb that heat into the internal part of the water droplet. So it sets up a thermal circuit that we call thermal conveyance. And it's really just many, many times more effective than plain water. So rapid cooling is the next superpower. So we can go on to the next slide. So this video is showing you how it absorbs that heat using the modified water droplet with polar tails on the non-polar tails on the outside, absorbing that heat into the polar heads and then into the interior of the water droplet filled with spherical micelles. This you're looking at this in a thermal imager view. And you're going to see how that heat is immediately absorbed and taken away by the F500. is a very, very efficient cooling agent. And the fact that it protected water droplet, protected by the F500 molecules, it doesn't react with metals fire. So all it does is cool them, which is great because it puts them out. Might have to unmute this video. Here we're using the torch on the back side of a piece of steel. You see how that energy is transferred through the steel to the other side and catches the finish on fire. Now we can apply F500 to the backside that's not on fire and actually cool the steel enough to put out what was on fire on the other side. Which is illustrating the fact that it absorbs heat very, very well. And he's able to walk up just a matter of seconds later with his bare hand on it and not experience a burn. So those benefits of that result in less water needed, less damage to the infrastructure or whatever's on fire. And if you've been on fires that involve asphalt roadway, fuel burning on those, it can actually cause damage to the roadway. This helps cool those things much, much quicker. There's less highway operation time, which keeps your crews safer. There's a payoff in that regard as well. Less resources needed. And one of the big things that I always dealt with as a fire chief is availability of units. So you have back-to-back calls. Availability of your units is a big deal. If you can more responsibly manage those resources by allowing them to spend less time on the scene, it's better for the public. Go ahead. And that less operation time, it results from more rapid cooling, more rapid encapsulation of fuel that might be on the roadway or anything like that, less time dealing with cleanup and removal of things that end up on the roadway. Go ahead. So the third superpower of F500 is toxin reduction. So those droplets in the spherical micelles encapsulate harmful hydrocarbons and carbons, volatile organic compounds, polynuclear aromatic hydrocarbons, those things that kill firefighters. And they can be acute toxins or they can be of a chronic nature. As we know, no combustion on the surface of the earth is perfect. It all puts out free radicals in the form of, because of incomplete combustion. Those free radicals then are looking for a way to get back together, to restabilize and to form new compounds. So they create just a rainbow of compounds that are both chronically and acutely toxic, and some of them are also flammable. So the smoke that you see coming off of a vehicle fire or a building fire or any other kind of fire, those are those free radicals rejoining up into VOCs and PAHs that number one are flammable and help the fire progress and grow. And number two are toxic. Go ahead, Hernan. So what you're going to see in this tire fire, number one, is that F500 puts it out very quickly, but going to test the stream on the ground here to make sure he's got F500 in the stream. And then, as you see and know, tire fires put off a very large amount of black smoke. what I want you to pay attention to is the fact that that smoke disappears very, very rapidly. So that smoke is gone already, and the fires go out very quickly. But why is the smoke gone? Where did that smoke go? Well, F500 interrupts the coalescence of free radicals. So it blocks that process of those free radicals coming back together and forming certain smoke. So those compounds are not created. So that interrupts that process, makes the fire and what comes off of it much more safe, less toxic, puts less compounds into the air, exposes firefighters to much lower level of those compounds, and exposes the public and the environment to a lot fewer compounds. So the quicker we can get the F500 on there in adequate quantity, the better effect we're going to have. So it's really important. We've got a recent study that was just put out in August by the Laval Fire Department in Canada, along with Ottawa University, that proved empirically that firefighters are exposed to fewer VOCs and PAHs when F500 is used on an SO fire attack. So, and then we have the Clemson University study. It was actually done back in 2006, and F500 is not new. It's been around for 25 plus years. But it's reaching a wider audience now due to the modern fuels that are out there, like lithium-ion batteries, and the fact that we need to find a replacement for foam. But the the Clemson study showed that there's a lot less toxins coming off of fires if we attack it with F500. And if you look at this graphic here, you'll notice that number one, the F500 on these, what they did actually, to explain this a little bit first, they took a glass funnel and they inverted it over burning toluene. Toluene is basically a piece of rubber. But they directed F500 across the plume of smoke in the inverted funnel. So they were not putting F500 directly on the seat of the fire. They were emitting a stream across the plume of smoke to see what effect it would have on the smoke itself, not the fuel. And they did it 3 times with plain water, and they did the same test 3 times with 3% F500 to see what effect it would have on the column of smoke, the amount of soot that was accumulated, and the number of toxins that were found in the air. So what they found from this is that it reduced the smoke by 68%, increasing the visibility of transmissible light in that smoke column. And as far as soot accumulation, which what they did was they measured the glass funnel by weight before and after the fire, and they were looking for the weight of the accumulated soot. They found a 97% reduction in soot accumulation when they used F500. And then when it came to toxicity, they did some high volume air sampling of the plume of smoke coming off of the fire. When they did it with the F500 at 3%, they found that they got a 98.6% reduction in the toxins that were coming off of that fire, just from directing the broken stream of F500 across the plume of smoke, not even onto the surface of the fire. So it really suggests that there's an interruption of vapor phase combustion. If you've ever seen vent point ignition, where you open a window and there's all of a sudden some flame coming out the window where there was smoke a little bit ago, that's your vapor phase combustion occurring. When the fuel gets enough oxygen and it's got the right mixture, it's burning in midair. But F500 interrupts that. It also interrupts the coalescence of free radicals into the toxins and the toxic soup that we call smoke. So some benefits from the reduced toxins include a reduction in the cancer risk, and that's what they were looking at in the Laval University study. the Laval Fire Department study in cooperation with Ottawa University, looking at the reduction in cancer carcinogen exposure to firefighters, and they did find, as I mentioned earlier, they did find that there was a significant reduction in the exposure to carcinogens when F500 was used on initial fire attack. Yes, you can use it later on to wet things down, or after, second line, third line, whatever you get it, but it's best to use it on initial fire attack so you have all of the benefits of it. Number one, faster fire knockdown, less time on scene, reduced cleanup, but also that reduced cancer risk exposure. Improve firefighter health when you're looking especially over the lifetime of a firefighter, how many years they're in the business or on the job or volunteering. You can reduce that risk over time through chronic exposure or reduction in chronic exposure. That's great. Less toxic runoff. So we're encapsulating the carbons and hydrocarbons out of the runoff as well. So we're making the runoff more environmentally friendly. Increasing visibility benefits everyone, not only firefighters, and accountability from firefighter to firefighter or person to person, but it also may help you find victims quicker. It may help victims get out on their own quicker if it's applied. Increase safety all around. So if we put F500 into a suppression system, for example, it can really increase survivability. Go ahead. So lithium-ion batteries, why does it put it out? How does it put it out? Why does it put it out when water won't? So we'll talk about that a little bit. We're going to talk about some testing that's been done around the world. So the first thing is comparative testing. So this testing was done by Kiwa, and a company called Johnson Controls commissioned the testing. So on the left, you're going to see a dry powder. In the middle, you're going to see a foam. On the right, you're going to see F500. So you're going to see the dry powder, very ineffective. These lithium-ion batteries, when they're packed tightly into a module like you're seeing, these are cylindrical cells. They have a high rate of heat production. The dry chemical, it goes onto the fire and it inhibits that combustion that you see for a little bit, but then as soon as you run out of dry powder, the fire comes right back. And that's because it doesn't cool. Foam was completely ineffective. It doesn't cool at all. But the F500 was effective with a very small amount. And some reasons for that include the fact that, it's got a surfactant characteristic to it, but it soaks readily into that, what I call the interstitial spaces, both between the cells and in the cells, and it interacts with the hydrocarbon electrolyte and encapsulates the hydrocarbon electrolyte as well as the flammable gases that are coming off of those battery fires. And we know due to several studies done as well as our own knowledge of the product that it cools anywhere from 10 to 30 times more effectively than plain water alone. So the combination of those factors comes together to make F500 effective at extinguishing lithium-ion battery fires. And Johnson Controls put out the report afterwards, and they came out and said that, and just so everyone knows, Johnson Controls is kind of a major competitor, of ours. They create a lot of foam products, and they own a lot of companies that create a lot of foam products and other products. But they did come out and say that dry powder was a poor extinguishing agent to use on lithium-ion battery fires, and that it should not be applied to lithium-ion battery fires. They did 3 tests, and they showed that foam was largely ineffective. And then they did the same 3 tests with that 500 and said that it can be recommended on lithium-ion battery fires. And not only did they recommend that, they now have adopted it for use for one of their lines of extinguishers for maritime. So they use it as well. So the Journal of Loss Prevention in the Process Industries was the Chinese study done to, they've done several studies on F500 versus water mist and lithium ion batteries. So for different purposes. For one, to see if it would do the job. Number two, to look at the cooling ability of it. But also they did another one to show how F500 encapsulated the gases coming off of these fires. So if you look at concentrations of hydrogen, that's what this graph is showing. So on the left, you have the concentration of hydrogen in parts per million. And along the bottom, you have a timeline. So the black timeline was without additive. The red timeline was a water mist. And then the blue timeline is with 3% F500. So with both the without additive and water mist, you have a spike of hydrogen production. Although it was somewhat less with water mist, you compare that to the F500, where there was almost no hydrogen production once the F500 went on. It proves that F500 is encapsulating those dangerous, harmful, and flammable gases. But one of the ways that they measured this was unique, is they actually measured the weight and size of those molecules that they were creating in the solution, and determined scientifically that they were taking on weight and size as they were encapsulating hydrocarbons. So I thought that was pretty unique. So this testing was done at TU Clausthal in Germany, and that's a learning institution. What we have here is basically a pack of 18650 cells that are ignited by some heating elements, and then that's let to heat up. And then over the top of that, you've got an F500 extinguishing agent system that's going to initiate here momentarily. And you're going to see how rapidly the F500 puts that out. I was looking for the word glow plugs earlier. They put diesel glow plugs in the battery pack and ignited the battery that way. As you're going to see, once the F500 goes on, fire goes out very, very quickly. The temperatures are regulated very, very quickly. And the fire is permanently extinguished. And that's one of the problems you run into when you apply plain water is that thermal runaway and the chemical reaction inside of those batteries and battery packs can continue on and repeat itself over and over for days up to weeks. So that if a vehicle gets towed away from the scene of the incident and doesn't get segregated or separated from other vehicles, or it gets parked inside of a building, it can catch fire again. So you may have seen some solutions from around the world where they're dunking cars in a vat of water for days until they know it's out permanently. You know, that's not the greatest solution either. So problematic. If we can put the fire out, we get F500 on the fire, especially on the battery module itself, allow it to soak in, absorb the heat, encapsulate the electrolyte inside of the batteries. That fire is not allowed to burn. Okay, so the core superpower of F500 is that it's environmentally friendly. It's fluorine free, it's biodegradable, non-corrosive. It's at a 7 on the pH scale. You can wash your turnout gear with it. It'll actually encapsulate the PAHs and VOCs off of the turnout gear after the fire. You can use it in your turnout gear laundering and post-fire decontamination as well. And go ahead, and go on to the next slide. Cancer, obviously one of our biggest concerns nowadays. It's killing firefighters, both because of the fluorinated agents in the foams, but also just the fact that there's a lot of synthetics in these fires nowadays, and as a fire burns, it's putting off these compounds and it's collecting on firefighter turnout gear. As you go to pull your gloves off and take your SCBA off, you're re-exposing yourself to it constantly. Even if you're a fire department that bags your turnout gear on scene, you're getting re-exposed as you're bagging it. And then back at the station, as you're unbagging it, you're getting re-exposed again. So if we can apply it on scene and encapsulate those harmful compounds right there on scene and keep that secondary and tertiary contamination from happening and stop dragging this stuff back to the station, it'll benefit everybody. And again, it's environmentally friendly as well. It stops the smoke production. All of that stuff goes out somewhere and lands on something, whether it's car door handles, playground equipment, yards, your roof. All of those compounds go somewhere. They don't just disappear. F500 stops the creation of those compounds, those dangerous compounds. And F500 is EPA listed as a surface washing agent as well. So, go ahead. So one of the things we do, we don't just manufacture the fire suppression agent, as we manufacture engineered equipment as well. So one of the things we have, that you probably saw in some of the videos, is called a TKO nozzle. Just a 20 GPM nozzle that has the surfactant in a 2-liter bottle attached to it. And it's very, very handy for a lot of different types of fires, as well as the decontamination of fire hoses and equipment after the fire. So just a real handy nozzle, and it's very well engineered, and you could buy spare bottles with it too, so you can have some agent pre-bottled, so you can switch bottles very quickly. And it's got the dial right on the side of it. It's just kind of an inductor built right into the nozzle. So, but you can adjust the percentage right at the nozzle. TKO nozzle in use. And you'll notice it's only a 20 gallon per minute nozzle, but it puts out this car fire very quickly. Modern car fires, all the synthetics, metals, and everything else. Typically, you're looking at 120 to 150 GPM line. This one, we're doing the same job with a 20 GPM line, using a lot less water, creating a lot less mess. Again, putting that fire out quickly, cleaning up your equipment, getting off the roadway, getting back into service, making yourself available for the next call. We do offer pressurized water can style of extinguishers with a few different wand types, and typically we just recommend that you mix a 3% F500 solution in there, and that way you're ready for a fire, whether it's class A, B, C, D, whatever. European water mist hose puts out a nice broken stream application, cools very, very well. And that's what was utilized for the testing by Kiwa in the Netherlands. And it works very, very well for most types of fire. Do work with a partner, Amerizorb, for a throw and go type of absorbent product. It's a peat moss based absorbent product. So if you're in a situation like I live in Nebraska, it's kind of cold today, where whatever dropped on the roadway freezes. This is an alternative for that freezing weather. Has very similar properties on a spill that F500 would. Absorbs the flammable liquid, makes it inert, makes it not inflammable. It's also a good partner with F500 after you've applied F500 on a highway spill, for example, and you want a way to absorb it, pick it up and get rid of it. The Amerizorb works very, very well for that. A video on how Amerizorb works. Kind of skippy on our end. Not getting any audio her in, but you'll see what happens here. Put, put some gasoline in the tray. Puts down some throw and go absorbent. It absorbs it. Your little time clock there on the lower left. After it's absorbed to a point where it's actually dry, and then try to ignite it. But it never lets that fuel go again. It's permanently consumed. So you can put it in an overpack or bag it up. Some people send it with the tow company and let them take care of the environmental part of it and dealing with the waste. But if, as you can see, trying to ignite it, once it's absorbed that fuel, it does not let it burn. So it's a really good partner to work alongside the F500 as a dry absorbent if you get in a situation where that would work better for you. There's a comparative analysis with your diatomaceous earth clay. You can see even after he's absorbed the gasoline and then put it on a second oil spill, it's still outperforming the diatomaceous earth. Leaves behind no residue. Pretty important from a cleanup perspective. You know, you're trying to get your crews back in service and available again. Pretty important that you have a couple of products like that that can work together for different situations. Another thing we want to talk about a little bit today is something we call a recovery mechanism for consumables. So whether you're billing for your hazmat incidents or your car accidents or even your building fires where you use consumables like foam and other stuff already, we also have a partner called EF Recovery that it's a billing service that will help you bill for agents used on the scene, whether it's F500, Amerizorb, or whatever it might be. They can even bill for other things if you desire their assistance and we work alongside of them, and we can help you make your use of F500 more economical for your fire department by employing that cost recovery mechanism. The simple app that you use to report your incident and the incident details to emergency funds recovery, and they do the billing for you and take a little bit of a percentage off the top. It becomes a way that you can recover the costs of the agent used and make that burden less expensive to you and eventually, obviously, the public. Oh, typical accident scene here. You've got a lot of resources, but F500 helps you reduce the overall burden of the call. With emergency funds recovery as a partner as well, we can help you recover those funds. All you need is a simple city ordinance or resolution by your county board to allow for the billing, excuse me, and that mechanism is then put into place. And typically it's the insurance companies that are paying the bill, and most people don't realize it's a part of their policy, but it is. So not coming out of the individual pocket. I know some people are concerned with. So EFR can work a couple different ways. They can use an API and access into your current fire reporting system, or you can separately jump on an application and report your incident for billing purposes, and then they do all the work from there. And if you do probably do EMS billing and transportation, it's very similar process. It's much more painless than an EMS call. There's a lot less reporting to do. They have customer service representatives that help you through the process too until you get your arms wrapped around it. If someone's not paying or slow to pay, they do all the follow-up. They can help with all kinds of incidents. And just have to be a fire. So one of the big things, one of the big ways that government tries to reduce taxes nowadays, or at least to control taxes, is by doing point of use or billing the user of the services, and that's what it's all about, is recovering those costs from the people that actually cause the consumption of the materials. So as we look back at what we covered today, big thing is we want you to know how versatile F500 is, and that it's not one-dimensional like a foam. Class A foams pretty one-dimensional. Class B foams even more one-dimensional. F500 is I like to say it's three-dimensional, and that's not just a pun, but it's very versatile. Covers all the classes of fire, and there's really no contraindications to its use. It'll help increase the health and safety of your firefighters, lowering the reduction, or excuse me, lowering the exposure to carcinogens in every type of incident, whether it's contact with a hazardous material spill or exposure to smoke and byproducts of combustion, lower exposure to contamination on the turnout gear, reducing the amount of contamination that comes back to the station, and reducing the amount of time you're spending on the scene. That's a big one. have a decrease in injuries by the fact that, mostly firefighters are spending less time on the scene. They're expending a lot less work. When you apply F500 on initial fire attack, you don't have as much work to do on the backside. Decreases the number of resources, lets you turn resources around sooner and get them back into service, whether they're units that were on the way to the call because it was a stubborn fire and it didn't go out. Now the fire goes out more quickly. Those resources can be turned around quicker, whether they've made it there or they're already on the scene. They can be released from the incident sooner and get back into service, become available for the next person that needs your services. It's also a big fact that it's environmentally friendly. There's no soil contamination. Actually, it's more than environmentally friendly, it's environmentally beneficial. You look at if you're concerned at all about environmental health and safety, you'll know that there's an environmental impact from every fire. We reduce that environmental impact through the application of F500 on initial fire attack to the end of the incident. There's less airborne contamination, there's less runoff contamination, and just less contamination overall. It's friendlier for the environment. Obviously, we hope you never have to use the technology, but if you're going to use the technology to help you out, F500 is a very innovative technology. And I'll tell you, one thing I've taught for years and years and years is that safety is born of effectiveness for a fire department. Just like a military, just like a football team, when you're more effective, you're more safe. And F500 can help you be more effective. There we go. One thing I do like to caution everybody about is when you're using F500, make sure that you've got F500 coming out of the nozzle before you make that initial fire attack, so that you can expect good performance. If it's not coming out of the nozzle for whatever reason, maybe a ductor's not performing right, a kink in the hose, foam pro isn't working great, then you're going to expect less performance, lower performance. But you make sure you've got F500 coming out of the nozzle in that initial fire attack, you can expect good results, good outcomes. Apologize for the choppiness of some of the video and some of our technical issues today, and I appreciate all your patience with us today. If you guys do have questions, I'm going to encourage you to go ahead and put them in chat so we make sure we cover all of your questions. But we will be doing a question and answer session here shortly. If you're looking at price, we're somewhere between Class A and B foam. Typically, we use exclusive distributors to distribute our products to the municipal fire service. So you're probably not going to be buying directly from HCT, and most likely through a distributor. You can probably skip the rest of this video, Hernan. All right. We reached that point. Hernan, you wanna, maybe if there were questions put in the chat, can you?
Yes, thank you, Dan, for helping us with the technical issues with Ron Lowry. I don't know, Ron, if you are here or you can answer the question.
Yeah, I'm here.
Okay, thank you, Ron. Ron, can you explain the last video because you participate in this video?
Yeah, so that last video was a vehicle fire we did up in Rensselaer County, New York. The cool one there, if you saw toward the end of the video, I was waving for the other chiefs to come over. We had actually had burning magnesium in the steering column that had fell to the floor, and you actually still had burning magnesium that was under a solution of a 3% F500 solution on the floor of the car, continuing to cool down. So not even spraying getting the reaction, but we actually had burning magnesium submerged in an F500 solution without getting any explosive reaction.
Appreciate everybody's patience today. Had a lot of participants from around the world, and glad you all were able to join us.